Hello everybody, so today I will talk about calculus. The topic today is about the application of derivative. We need to prove that x over 1 plus x is smaller than log of x plus 1 and smaller than x for x is greater than 0. So I will show you the technique how to answer the question. Before we need to prove this one, we need to know that first the derivative of the function greater than 0, it should be about increasing of the function. And we have the second one, if first the derivative of the function is smaller than 0, so we can say that that's the decreasing of the function. So we need to prove this one first. So we put x over 1 plus x on the right. So you got about zero is smaller than log of x plus 1 minus x over 1 plus x. So we put f of x in here equals for this one. Now we do first the derivative of the function. So you got about 1 over x plus 1, and then we have the next one, that's about 1 plus x to the power of 2. Later that we do first the derivative of negative x minus negative x multiplied with 1 plus x in the first derivative. This one we change to negative number 1. This one we don't have anything, that's in number 1. Negative number 1 multiplied with number 1 and x, you got about negative 1 and negative x. Negative and negative, you got about positive x. This one you got about 0. Next, about this one we will about multiply with x plus 1 in here. So you got about x plus 1 on the numerator. Number 1 minus number 1, you got about x right now. Next, if we look carefully, x is greater than 0. In here, x should be about positive. Denominator we have the power 2, that is about positive. So we can say that first the derivative of the function f of x is greater than 0. Now we have the next one, f of 0. It means we put x equal to 0 in here, and that's about this one. As you can see that log of number 1 is about 0. This one is about 0. So you got about 0 in here. And we know that x is greater than 0. And we also know that first the derivative of the function f of x is greater than 0. So it means that's the increasing of the function. So we have f of x is greater than f of 0. So we have f of x is about this one, and f of 0, that is about number 0. And now we move this one on the right. And you just rule on the first one. Now let's rule on the next one. So we put law of x plus 1 on the right. And we do the same thing. So I choose about j of x equals for this one. And now I do about first the derivative of the function. We got about 1 minus 1 over x plus 1. Now we do about common denominator. So we got about x plus 1 minus 1, and we have x plus 1. So you got about x over x plus 1. As you can see that x is greater than 0 and x plus 1 is greater than number 1. So everything in here is about positive. So you say that first the derivative of the function g of x is greater than 0. The next one, we put about the value g of 0 in here. So we have number 0 in here and 0 in here. So you got about 0 minus 0. So you got about 0. We have x is greater than 0, and we know that this function is greater than 0 in first derivative. So we can put about j of x is greater than g of 0, and g of x is about this one, is greater than the value of number 0. So we put about x is greater than this one. After we prove in here, after we rule shooting in here and here, now we can connect together. So we have this one is smaller than this one, and this one is smaller than s. For s is greater than 0. That's the end. Thank you for watching.